For this video, I'm going to open the data, show you how to open the data on hospital bed projections. This is a very useful topic during COVID-19, projecting how many hospital beds that hospitals will need, right? Because the hospital bed shortage in California and other parts of the country. So just like in the other videos, we type use to open the data, and then we give it the internet link to the name of the data file, which here it's beds.dta, and then we type comma clear. Comma clear just clears whatever data is before it. So if there was something open before that, clear would make sure that whatever data was there before is cleared. That's the do file there. Remember, I post these on Stata, or try to remember to post them to Blackboard each week. It says beds.do, beds.do. That's the program file. So that has all of the exact code you need. And then you could highlight the code and press play in the top right and run the entire program. So that's all you really need to do the assignment, is that do file that I post on Blackboard each week. I'm just going to walk through the different parts of the do file list. You can see here as the data is, I have two things. I have observed and cases, and they're the same for years before 2020. Right, and then they're blank for the future years. I want to show you how to predict it for years after 2020. So how we do this is we have to do a regression equation. So regress cases on year. That's just going to run a time trend through the number of cases, through the number of hospital beds that we'll need. And I'll show you this in more detail in the graph later. And then we're going to, so what this regression does is it says that cases is a function of some constant, negative 74,000 plus year times the coefficient there, 37. That's how you calculate how many cases there'll be in years after 2020. So then if we type predict if year greater than 2020, it's going to use that regression equation, the regression model that it just fit. And it's going to fill in the data for the years after 2020. Again, go back to the do file and see all the different things. So open the data. I keep listing it out at different points in the program to view it, right? But once you have the regression, you could use the regression to predict it for year after 2020, or what the book calls projecting hospital demand. So run a time trend through it. And then when you model the trend over time, see and predicted what it did, it filled in, is it used that regression equation to predict how many beds will we need in 2022, how many in 2027, and how many in 2032. Okay, so now I just want one thing called cases that has however many there are. Right, so we'll say that cases is just observed. It's just whatever we observed before 2020. But then for years greater than 2020, right, for years 2022, 2027, 2032, I put them in 5-year intervals. It's going to use predicted. Okay, so now let's list that out, and then you will see that it fills in the cases variable. Fills in the cases variable for each of the years. So before 2020, it's going to just put the observed, what we observed, because it already happened. And then after 2020, it's going to use the prediction from the regression equation. Use the forecast from the time trend. So alpha is a linear fit, a linear time trend with a confidence interval. And we could sort of visualize this in the graph, and then scatter. So put dots, put a scatter plot, dot plot, dots for each of the cases over the years. Okay, so you can see there, you can see the time trend running through it. You can see the confidence interval in gray, right? It doesn't know exactly what it is. It's going to predict it. It thinks it's going to be somewhere in that interval. And you can see the cases. So they're not on the line. They're observed. But then it's sort of that line, that regression line, that average running through the middle of them before 2020. And then after 2020, it just predicts whatever's on the line. So it fits that line using the regression, using an average, runs that trend through it. And then for after 2020, it thinks they're just going to be whatever exactly the line is. Why aren't they exactly on the line before 2020? Because we observed whatever it was.